Hey, hello and welcome to today's GFG problem. Today, hope you're doing well. So let's say today's problem majority element. Okay, so what the problem is saying is we'll be given an array. We want to find the majority element in the array. If no majority element exists, return -1. Okay, a majority element is an array in an array is an element that appears strictly more than array dot size by 2 times in the array. So more than half times, more than half of the array, the element should appear. Okay, and then it will be called as majority element. So here in this example, what will be the majority element? It is 1 basically. If you see what is the frequency of 1, it has appeared 4 times. Okay, and what is the size of array? 1, 2, 3, 4, 5, 6, 7, 7. So 4 is definitely greater than 7 by 2 times, right? Which is 3.5. Okay, so that is why 1 is a majority element. Okay, that is why 1 is a majority element. So I hope you have got the ask. Now, how can we solve this problem? So first of all, let's see the naive approach again. What we can do is we can have a map. We can add the element and the frequency in the array. Okay, so this is how the final map look like. Okay, 3151. Okay, so here if you see, we'll just go iterate to the map. Okay, whichever element's frequency is greater than half of the array, right? Is greater than half of the array, then we'll treat that as a majority element and we'll return. Okay, so this is the naive approach. Okay, now let's see the expected approach. So there are um, I think there are a couple of ways to solve this problem. But again, since it seems that Geeks for Geeks is giving the bit manipulation algorithm like problems, so we'll solve this using that problem. Okay. So here, for example, what we'll do is we'll write down all the binary representation of the elements. Okay. 001, 0010, and 0001, 0011, 0101, and finally 0001. Okay. So we have the binary representation of the numbers. Now let's just write the indices. For example, here 0, 1, 2, 3. Okay. Now what we are going to do is we'll start from this 0th position. Okay, and we will count the number of set bits. Okay, we'll count the number of set bits. Okay. So what we're going to do? Let's say what we're going to do, we'll take an x variable. Okay, we'll take 1 and we will left shift this 1 with I times. Okay, and what is this I will be the index, right, for the positions. Okay, so we'll have a for loop. You know, right, the size of integer is 32 bits, right? 32 bits. So we're going to have for loop int I equal to 0 to 32. Okay, and here what we're going to do, we'll have an x variable x equal to, we will left shift 1 by I times. Okay, so in that way we'll be able to check for each bit position the set bits. We'll be able to check the set bits for each bit position. Okay, so here for example, let's say now since I is 0, right? So 1 left shift by 0 will give us what? Will give us 1 itself. Will give us 1 x equal to 1 itself. And what is the binary representation of 1? It is 0001. Okay, so what we're going to do, we'll start from this particular element, right? We'll do the AND with this particular x. So 0001 and 0001, right? So we'll get what? Again, 1 only. 1 and 1 will give us 1. Okay, so what we're going to do, we have found the set bit position here, right? We have found the set bit position here. So we are going to increment count. Let's say, let me write count over here. Count equal to 0. So we'll increment count, okay, to 1. Okay. Now we'll come to the next element. Again, the bit is set here. We are going to do the same thing. This and x. This and x. Okay, this and x. Okay. Again, we have found the set bit. We are going to increment the count. Okay. We'll go to the next element. Here, there's no set bit. We'll move ahead. We come to this particular element. Okay. Again, the bit is set. We are going to increment the count. Okay. And then what we're going to do, again, we'll come to the next element. We'll the set bit, so we'll increment the count. Next element, we'll increment the count, the set bit, right? Next element, we will increment the count, this set bit. Okay, so the count is 6 now. Okay, so the count is 6. So now we have done iterating all the elements for this particular bit position. Okay, for this particular bit position. Okay, so whenever the count for a particular position, if it is greater than half of the array size, if it is greater than half of the array size, so what is Array size is 7 divided by 2, half of the array size. 6 is definitely greater. The count 6 is definitely greater than 7 by 2. Okay. So what we are going to do? We are going to have a candidate, right? A candidate which will be the candidate for majority element. So here the candidate would be, let's write candidate here. Okay, candidate equal to 0 initially, right? So what we are going to do, if for a certain bit position, if the count is greater than half of the array size, then we will we will do OR operation with that candidate. We'll do OR of X and the candidate. So what is the candidate now? It is 0, 0, 0, 0. Just be with me, you understand. And what is the X value? X. So what we want to do is we want to set the bit position. The bit position, that is this particular bit position into this candidate. Okay. So let's do OR 0, 0, 0, 1. Okay. So 0, 1 or 0 or 1 will give you 1, 0, 0, 0. Okay. So we'll just do OR. So here now, what is this binary representation? It is 1. Okay, it is 1. Okay. So now candidate will hold 1. Now what we are going to do? We are going to, so let me write candidate here. Candidate again, currently it is 1. Okay. We'll come to the next position. Okay. Now what we're going to do? X equal to 1 left shift by I. So 1 left shift I will be 1 now, right? So 1 left shift 1. So what? So for example, if the binary representation of 1 is 0, so left shifting by 1 will bring the 1 here. So it will look like this, 0, 0, 1, 0. Okay, 0, 0, 1, 0. So this is a bit position. This is a bit position. So we are going to now check for this bit. Okay. So here the bit is not set. The bit is not set. The bit is set here, right? So how we'll get whether the bit is set or not? So whatever is the element, for example, this is the element 0, 0, 1, 0, and the current x is this, right? So 0, 0, 1, 0. So we are going to do and of x with each element. So here 0, 1 and 1 will give you 0, 0, 0. Okay. So this particular bit is set. This particular bit is set. So we will increment count now. So now count will be count. Let's say, let's represent C with count. Count will be 1 now. Okay. For this particular bit. Again, bit is 0. This particular bit is set again. So we'll increment the count. This bit is not set. This bit is not set. So final count for this particular position is 2 only. Okay. Is 2 only. So that means, since it is less than half of the array size, okay, so that means we won't add this particular bit position. We won't set this particular bit. Okay, we'll move ahead. Okay, again, we'll come to 2 now. So we'll left shift 1 by 2 times. Okay, 1 by 2 times, which will be what? 0, 1, 0, 0. So 1 was here, so it will come here. Okay, now again, we are going to do and with all the elements. Okay, so here the bit is not set, 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 bit is set here, bit is set here, not set here. So the count is 1, which is less than half, we'll ignore it. Similarly, we'll go to the next one. Whatever is the x, we'll do AND operation with each element. Bit is not set, not set, not set, not set, not set, not set, not set. Okay, so we are done. We will iterate till, till 32 positions, right? But since like for just demonstration purpose, we are going until 4 bits only. Okay. So final, the candidate is 1 till now. Okay. So it is still candidate. We cannot say it's a majority element. So simply now what we're going to do, we will iterate through all the elements. So what does the array look like? Let me write here. So the array looks like this, right? 1, 1, 2, 1, 3, 5, 1. Okay. Candidate is 1. So we will count, will compare the number with this candidate. Okay. And if it matches, we'll increment the count. So here 1, yes, it matches. Increment the count to 1, count 2, count 3, count 4. Okay. So we have got 1 4 times. And what is the size of the array? 7 by 2. Okay. It is greater than half of the array. That means candidate is the majority element and will return the majority element. I hope you've got the intuition. Okay. So now just let's go and code. Okay. So before going to the code, I'll just request you please subscribe to the channel, like the video. Okay. So first I'll implement the Java code followed by C++. So here let's have, yeah. So let's have a for loop int I equal to 0, I less than 32, the size of the integer. Okay. Then what are we going to have? Let's have x equal to 1, left shift by I. Okay. Let's have count equal to count variable to track the count of the set bit position. Okay. Then j equal to 0, j less than air dot length plus j. Okay. And then if air of j and x, if it is a non-zero, that means the bit at the ith position, it is a set bit. Okay, it is a set bit. So we will increment the count here. Okay, we'll increment the count. So this will check. This will check for the set bits, right, at the ith position. Okay, once we are done iterating all the elements, now we're going to check if count is greater than add dot length by 2. If it is greater, we'll also have a candidate here. Let's have a candidate variable. In candidate equal to 0, candidate or equal to, okay, x will do. Okay. So here we are setting that bit, right? That bit position, right, at I and in the candidate, basically, in the candidate. Okay. Now what we're going to do, we have the candidate now. Now we will confirm whether it is really the majority element. Okay. So we'll have a count variable again. Now we will iterate through num and we're going to compare candidate equal to num. If it is, then increment the count. Okay. Now we'll check here if count is greater than add dot length by 2. If it is a case, then the candidate is the majority element. So return the candidate, else return -1. Okay. So let's compile and run. Okay. Let's submit this. So the time complexity here will be n because we're iterating the n elements and log 32. Okay, log 32. Okay. So yes, so the test case has successfully passed. Thanks for watching. Please don't forget to subscribe to the channel, like the video. Let's quickly see the C++ code. It's almost same, not much difference. Only difference is there it was array.length, here it is array.size. That's it. I'll attach the code in the description section. Thanks for watching. Please subscribe to the channel, like the video. I wish you a very happy, healthy, wealthy, successful, and a great day. Thank you so much.